You've seen that describing the relationship between two continuous variables is an important first step in your statistical analysis. The scatter plot is an important tool for describing this relationship. Plot your data. Given the importance of scatter plots, let's start our exploratory data analysis by looking at them. Scatter plots are two-dimensional graphs that you produce by plotting the values of a variable on one axis against the values of another variable on the other axis. Typically, the predictor variable is on the x-axis and the response variable is on the y-axis. Here's a question. What do the coordinates of each point correspond to? The coordinates correspond to the values of the two variables. You can use scatter plots to examine the relationship between two continuous variables. You can also use scatter plots to detect outliers and identify trends in your data. Other uses for scatter plots include identifying the range of x and y values and communicating the results of a data analysis. Here we have some possible relationships between continuous variables. In one of these scatter plots, a straight line describes the relationship. Which scatter plot shows a linear relationship between the two variables? This scatter plot shows a positive linear relationship between the two variables. As the values of one variable increase, the values of the other variable increase as well. Now, which scatter plot shows curvature in the relationship? This scatter plot shows a parabolic or curvilinear relationship between the two variables. Later, when you learn about fitting a model to the data, you'll need a quadratic or squared term in the model for this type of data. Next, which scatter plot shows a cyclical pattern in the relationship? This scatter plot shows a cyclical relationship. You often see this type of relationship in seasonal data, where the pattern repeats itself over time. Finally, this scatter plot displays a random pattern of points. No clear relationship exists between the variables.